In this short video, we're going to cover some of the parameters which are required for the moving load analysis. This is in case you are running an influence surface analysis and you want to determine the critical truck positions for different effects on the bridge, whether support reaction, displacement, shear, moment, lateral, bending stress, etc., etc. The first thing you've got to define is the number of truck models. In this case, it's equal to 6. And for each truck model in this dialog, you specify the number of axles and the lateral distance between the wheels. Then based on this information, the dialog, this table on the right will specify for each truck model, I have 6 in this case, the distance between the axles, as well as the left wheel load and the right wheel load. Of course, because we are in the American AASHTO context, you need to specify design lanes and multiple presence factors. So by default, you will have really the factors that are compliant with AASHTO, therefore 1.2 for one design lane loaded, and then 1, 0.5, 0.65, 0.65, etc. In this table, you specify the position of the design lanes with respect to the bridge deck. And in case there is any doubt, you can click this button here. Okay, so you need to specify the width of the design lane. By default, it's 12 feet. The distance between the center line of the design lane and the left edge of the deck, and also the minimum distance between the design lane edge and the left wheel load, okay, or right wheel load. You can also define a design lane load width of 10 feet, and of course you can specify the magnitude of the design lane load, which by default following AASHTO is equal to 0.64 kip per foot. If you click this checkbox, as the explanation here says, the software will compute the vehicle load configuration that produced the largest range of the effect. So that would be maximum minus minimum. It will look at the stress range, which is what you need to find if you want to use SN curves to determine the fatigue life of your detail. Additionally, you've got these two checkboxes. If checked, the reverse truck models will be automatically generated for the analysis here to include both directions of travel. And additionally here, there is now an option to consider centrifugal forces on curved bridges. So if you click this button, you will then be able to include these effects. If you double click, you can then have two options. You can either specify the wheel factors directly, one for the left wheel, one for the right wheel, or you can include these wheel factors automatically by specifying a design speed for your truck, maybe 50 mph, maybe more, etc. So of course you need to stay reasonable depending on your curvature, and you may include the relieving effect of the super elevation. Okay, these factors were checked. They are consistent with some of the design examples produced and available publicly on the AISC website. And finally, you've also got these additional two buttons. If you click this button, you will have the default truck from AASHTO with the variable spacing between 14 feet and 30 feet. Okay, so that would be between the second and the third axle. That would be for the single truck. The sixth truck model would be the tandem, of course. And then we now cover as well the Canadian code, the Canadian Highway Bridge Design Code. And you've got actually two options. The single click will generate the CL625 truck load, while the double click will generate the corresponding lane load. These are slightly different loads which depend on the bridge type. And for more information, refer to the Canadian Design Code. So I hope this covers some of the basics here in the moving load analysis dialog now included in Embrace 3D. Thank you.